This is the Amp Hour Podcast, recorded February 4th, 2013. Episode 131, with guest Andrew Seddon. Necessary, Networked, Novelty. Welcome to the Amp Hour. I'm Chris Gamble of Chris Gamble's Analog Life.
And I'm Andrew Seddon, embedded engineer and co-founder of Circuit Hub.
Well, welcome, Andrew. Thanks for coming on the show.
It's a pleasure to be here, Chris.
So we talked about your startup last week, and then we've had some changes in our guest lineup, and then you were nice enough to come on the show this week. We'd actually talked to you about coming on the show a couple weeks from now, but you were able to move up your schedule, and we're really glad that you're able to come on here. So you sent me an email, and you had said, "Oh, well, I have some corrections about what you said last week," and I'm like, "Well, you should just come tell us, right?"
Yeah, it was. So it was funny actually. But John, my co-founder, was sat there listening to the podcast and listening to you guys discussing Circuit Hub, and it's a fantastic discussion actually, and it was really insightful for us because we kind of got to see some of the things that people typically misinterpret about what we're doing. Mm-hmm. So I think I then pinged you an email, sort of, with a couple of corrections for what it is that we're actually doing. And then, obviously, happy to come on here and talk about it too.
Yeah. Well, before we get into that, so why don't you tell us a little bit about your background? Because when you and I first started talking about Circuit Hub in general, I was really amazed because, you're doing this high-level software startup with this really beautiful UI and this interesting concept that Dave and I had talked about previously. But you actually come from an embedded engineering background. So where did you start? And what's your electronics story?
Yeah, sure. So but very much from electronics. I mean, some of my earliest memories are sort of tinkering around with electronics and piecing circuits together. Really, that's for me. It's been a big jump to move into the web development space. I started very, very low level electronics and building circuit boards, and to some extent, sort of doing embedded software as well. But certainly, sort of moving up into the web side of things has been a big jump.
Okay. Cool. And so you started out over in London, right? But then you've kind of moved around a little bit. What were some of the places you worked at over there? Yeah,
so I mean, I actually I went to university up in Leeds and did electronics engineering up there. But probably in the last year that I was there, I moved down to London, and when I was there, I basically I sort of, although I really enjoyed studying electronics at university, I wasn't sort of so interested in the theoretical side of things. Like I always really wanted to try and actually build stuff. So pretty much in my last year of university, I kind of started, I guess, a kind of small design consultancy. And I kind of had some interest in that from a small startup that was based down in London called TurnSafe. And they were basically doing a really cool project it was kind of a safety system for articulated trucks.
What's an articulated truck? Hopefully I'm not the only one who doesn't know what that is. But
yeah, so an articulated truck is basically it's a truck that pivots in the middle, right? So so you have the cab at the front and then the trailer behind, and then the pivot in the middle of it. Basically, what that company was doing was a mirror that moves at the same time as the trailer moves.
Huh.
And what's useful about that is that it allows you to see the images in the mirror whilst the truck is actually turning.
Wow.
So really, the system really helps with safety. And so they basically wanted somebody to come down and on the basically work on a DSP system, an embedded computer vision system, effectively. So I pretty much dropped out of my last year of university, went down there and helped these guys to design this system. So I really just kind of fell into doing design consultancy.
And so that was DSP type stuff. That was it was actually using like camera feedback, that kind of idea, or what was that?
Yeah, I mean, but basically, so that system was they had a camera that looked back at the truck, and so it looked back at the carriage behind the truck, and from that you can then compute what the angle of the trailer relative to the truck at the front. Huh. And you can then sort of transform that to come up with an angle for the mirror itself. So it's kind of like a pretty interesting control system, computer vision system there. Yeah. And then the challenge was kind of to get all of that software actually running on an embedded system and kind of make it reliable. And obviously if it's a safety system, this thing has to be very reliable. So yeah, I mean that was my first, I guess, real commercial experience with electronics. But certainly before that, I'd been doing an awful lot of things as a hobbyist.
Oh, what kind of stuff was that?
So I guess probably the first project that I can think of that I ended up doing was I used to be really into model rockets, so sort of firing model rockets, and what I wanted to do was be able to track those rockets, so that I would know the coordinates of where how high the rocket was, where it was, etc. So I actually did a project. The idea was I was effectively, although I didn't realize it at the time, was trying to design pretty much like a GPS system. Huh. And this was a really, really early project, and so I ended up building this kind of what at the time was a pretty high speed timer system. So I had this timer running at 100 megahertz, and the idea being that I'd be able to count or time the sort of round trip of a radio signal, so that I could then sort of pinpoint the location of this model rocket. So I sort of put this high speed timer together, and then thought that the whole radio side of it was going to be the easy thing. And
then I just do some RF, and what's the big deal, right?
Exactly right. I mean, the whole sort of Fourier theorem thing was not something I was aware of at the time. So that didn't quite work out as originally intended.
Well, that's interesting. And so then so this was all still in London, though, right?
Yeah, I mean, this was generally around London. I mean, I sort of grew up around Cambridge area, so this would have been either in and around Cambridge. I actually had before university, I was working as I was working at another startup called Active RF. Mm-hmm. And those guys were doing basically RFID tagging systems, so active RFID tagging systems.
Okay. So it actually receives the signal, it harvests a little bit of the energy, and then actually bounces back an intelligent signal versus just the the response of the chip, that kind of thing, or is it something else?
Yeah, I mean this wasn't quite so advanced at the time. I mean this wasn't really kind of energy harvesting. They actually had it was pretty old fashioned to have put some batteries in them. So you'd have, I guess it's not really how you would think of an RFID tag today, which is kind of a very thin, sort of looks like a bit of paper. These things were more kind of mobile phone sized, I guess. And they have batteries in them and RF systems, so that you would get kind of a low frequency trigger from an RFID gate, and then they would ping back a high frequency response.
Huh. Okay.
So that was. Yeah, I mean that was. I originally didn't really actually have any intent to go to university. I'd been fiddling around with electronics for probably a few years whilst at school. Applied for this job at Active RF. Went in for the interview. We got on like a house on fire. I showed them some of the electronics I was working on, and these guys were just great. When can you start? So that was a really fun year. Actually, I got to basically do what I was doing anyway, but sort of have somebody pay me to do it, which was kind of nice.
Well, that sounds like the classic example of bringing in like a portfolio type piece, and then that being the centerpiece of an interview, right? Where you walk in, this is what I made. Let's talk about it. Oh, okay. Let's forget all these questions we were going to ask most people, but most people love talking about that kind of thing.
Exactly. I think that's a great. It's a great thing to do because even to this day, if I'm actually interviewing people, I mean that's kind of how I will pose the interview, is that I will try and get them to talk about something that they're passionate about, right? Because I think if you are, if you're a maker, if you're somebody that, you're an engineer and you actually make stuff day to day, you and you're good at it, you will have projects and you'll be passionate about the things that you're working on. Yeah. So it was a great experience, that initial interview, and I think it's definitely something that's kind of carried on. I've sort of followed through as I've switched roles in that sort of space.
Yeah. So I was going to ask you in general. I mean, I know a couple people over in the UK, but what is the London scene like? I mean, I guess that's something that I don't really have much exposure to. That's the thing I really enjoy hearing about, even within the States. Different parts of the country, like my part of the country is real big on industrial. Out in California is big on RF and a lot of other things like that. Midwest is generally military, stuff like that. But what's the London scene like?
Yeah, so I mean, London itself for electronics is pretty barren in terms of hardware itself. Okay, and I think that's simply because there's so much going on elsewhere in the UK. Okay, I mean the kind of traditionally, I guess probably the home for hardware would be Cambridge. Okay. That's sort of certainly where companies like ARM. Oh yeah, Cambridge Silicon Radio. There's also quite a few sort of semiconductor startups as you sort of on the they call it the M4 corridor, which is kind of west of London. So I think generally, like in terms of hardware, it doesn't actually tend to happen in London itself, just simply because of the property so expensive. Would be my guess. And if you have to set up a lab, then it's pretty crazy to be paying $5,000 a month for a lab in central London when you don't need to be there. Right. And the cost is half as much if you go out to Cambridge, Oxford, Bristol, wherever it may be. So London itself, for the actual sort of hardware scene is on a professional level is pretty quiet, but actually on an amateur level, I think is actually sort of growing pretty fast, the same way that it is or seems to be sort of all over the place. Actually, I think a couple of years ago now started a hack shop in pretty much in central London. Oh, yeah. So. Last time I checked, I think they sort of had a couple of thousand members, and that's basically a place where you can, they have all the tools set up for you to use, so you can etch your own PCBs. They have the CNC mills and all sorts of equipment that you can use if you actually want to make stuff. Yeah. So the actual amateur scene, I think, is really on the up and up, but professionally, it tends to get sort of budged outside of London.
Yeah, it's interesting. I mean, especially in city scenes, because space is at such a premium that like hacker spaces can really do that with, there's no way you're gonna. I mean, very few people will have, like routing tables in their apartment, right? Just because it's not economical, it's not allowed sometimes. So those hacker spaces really benefit from that, and that's great. But yeah, I've actually lamented that before in the past about being an engineer, and it's like, well, I'd love to live in like a metropolitan area, but good luck. It's not that it doesn't happen. It's just very few because of that same problem you said. That even like in a Cleveland, right, where downtown space is not necessarily difficult to find. It's just the amount you can spread out in the suburbs or in the outlying areas is often just so much more, and tax codes are often different. It's just set up that way, and it's kind of unfortunate because you don't get to experience the lifestyle. You have to live a little lower key lifestyle if you want to live close to work.
Yeah.
So
it's funny actually. I mean, I do think things are really changing. You kind of have these tech shops and hack spaces are springing up now, and I mean, even as much as or as near as 3 or 4 years ago, that wasn't really an option.
Yeah.
I know, for instance, now over in San Francisco, they have a tech shop there where you can go and use all of the equipment, and these things are pretty, they're pretty well equipped. They've got a lot of what you would need to do things even on a professional level.
Oh yeah. A lot of companies will probably see popping out of there in the next couple of years as well. I mean, they're good not just because of the equipment, but also because of the concentration of other like-minded people. That whole kind of critical mass thing really helps.
Yeah, for sure. And I think that it's things like that are really contributing to this rise in hardware. I think traditionally it has been incredibly prohibitive to get into this stuff on an amateur level because I think the bar's so high now with what you have to do in hardware to do something original.
Yeah.
If you're doing something with some complex FPGA or DSP specifically if you're trying to make something for a consumer level, it tends to be very small. And if you're trying to make small electronics, then using small packages and high density PCB technology, this isn't the sort of stuff that you can do in a etch tank at home, right?
Right.
You need this equipment. So yeah, I think it's fantastic, and I just think it's a shame that it wasn't around 5 years ago when I could have used it a lot more.
Right. So I guess that leads us into it. I mean, so now you are, what kind of programming language are you doing? Like Ruby and high level stuff, JavaScript? I mean, high level HTML5 type stuff, Node.js. Is that right? I'm looking at your LinkedIn profile.
Yeah. So we sort of jumped in on the deep end, really.
Yeah.
We pretty much use a JavaScript stack from top to bottom.
Okay.
We actually use CoffeeScript, which is one of these newfangled compiled to JavaScript languages.
Okay.
And we kind of, I guess we bit off quite a big problem because we knew what we were going to have to do was pretty cutting edge by anybody's standards, right? Not just cutting edge by web development standards. It was this was generally a lot more than anybody had done before in any field, not just electronics. So we had to build this application in a very different way to a traditional web application, which has effectively meant writing an awful lot of JavaScript, an awful lot of sort of front-end GUI framework stuff, which was very, very different for me.
So was it actually so obviously for people not paying attention to the first part of the show, we're talking about Andrew's jump to Circuit Hub, but were you doing software before that? I mean, was it like was this something that you had already been doing, higher level languages, or was it, okay, I am an electronics designer, I see something that I want to make, and now I'm going to go develop software?
Yeah, I mean, I'd always been involved in software in one form or another.
Okay.
I mean, a large part of what I did was kind of embedded systems development, so it would generally be much lower level type stuff. So, I mean, I spent quite a lot of time writing C code, doing. I would tend to do either sort of really low level driver stuff or algorithm stuff, and quite a lot of kind of optimization of algorithms.
Okay.
Which, is obviously a very different end of the spectrum to writing a web application.
Right. I mean, like, so my C code is just horrendous. I've been getting back into it, and it's not great by any stretch. But then does someone come and say to me, okay, well, now we want you to go write some high level abstracted, object oriented language? It's like, Okay.
Yep.
I mean, so did you do that to yourself? Was that something where like, okay, well, I guess I'll just go learn this stuff? Is that kind of the idea?
Yeah, I mean, it was really really a case of just
Masochism.
yeah, but butting my head on a brick wall until it stuck. Really, um, I mean, it's funny actually. I sort of I was looking at some tweets the other day that I made at the time, basically just in expressing my frustration at how stupid it is to do web development. You know, all of the weird hoops that you have to jump through to make these things work. And I think the biggest difference is that you're building on top of other people's abstractions.
Yeah.
So it's not like you can work these things back from base principles, right? You know, if you're working on an embedded system, you can say, okay, well, I can look at the registers, and then pretty much everything above that is under my control.
Right.
And I can see the code, but when you're working on the
absolute
web
worst
stack,
case scenario, you go and you say, well, whoever wrote this or whoever designed the silicon messed it up, right? And that's very rare. But then now you're as a web developer, you're looking down on these abstractions, and you're like, well, there's so many places to mess up, right? There's so many more variables.
Yeah, I mean, it's you can never comprehend the whole stack that you're working with. You know, you're always sitting on top of somebody else's abstraction, and I think the big thing with that is that it means you kind of have to you have to learn their arbitrary rules and the arbitrary decisions that they've made about how they're going to present that abstraction. So it kind of, to me, it almost feels kind of a lot less pure in a programming sense. But it is kind of almost countered by the sort of instant gratification that you get, where, you know, if you're designing an embedded system, you might work for 3 months to make an LED flash.
Yeah.
Whereas in like 2 days in web development, you can sling up a website.
Right.
So it's a kind of different.
Yeah. That's the basis of startup weekends, right?
It's well, it's funnily enough, actually, they it seems like they're starting to get some hardware startup weekends as well.
Yeah, I saw that announced. Didn't Upverter and someone was co-sponsoring that this coming. Yeah, so
we're actually going to be co-sponsoring. So we at Circuit Hub will be co-sponsoring the hardware hackathon it's going to be held at Y Combinator.
Okay. So tell us a little bit more about that.
Sure. So actually, I mean, we recently had our Circuit Hub launch. We've been kind of working away on this for I guess probably a year in earnest now. Actually, sort of sitting there and really heads down writing code and testing out this product that we're building. And we launched last week. I think this was. It was sort of last Tuesday. It's all been a bit of a blur since then, so I'm just trying to remember. But I think it was last Tuesday we launched. And so I think we sort of we mentioned in the press release for that we went through Y Combinator at the start of this year. So this was kind of January to end of March time. We sort of participated in the Y Combinator Winter 2012 batch, and it was a fun experience.
Okay, so the actual hackathon though, so that's going to be when is that happening? Yeah, so the hackathon, I need to check my dates on that actually, but I think that's pretty. I think I just found it actually. Is it? Is this the right one? Oh yeah, there you are. Yeah, you're on that list as well. So it's February 23rd, 10 a.m. to 10 p.m. Is that right? That sound right? Yes, that's the one. Yeah, so you can apply for it now. You can you can go on there and apply for it now. You can. There's going to be about 80 teams. Wow. Maximum of 80 teams accepted. Yeah, it's should be good fun. And there are other names that we recognize on here. There's Lockatron, which is the web-enabled lock. There's Octopart, which is they're not scrapers. They kind of pull in other like DigiKey and Mauser. They kind of go out to all the different distributors and search for stock and stuff. And then there's Pebble, which is I think that's the watch, right? There's not a different Pebble.
Pebble is the smartwatch.
Yeah. And then Upverter and then Y Combinator are doing that as well. So all great. That's kind of like you guys, all of you are kind of like the intersection of hardware and software and kind of getting stuff done. So that's cool. That's really cool. I don't know though. So what do you think? I mean, so you've been doing embedded for a long time. You get 12 hours to do hardware, and really it says 10 a.m. to 12 p.m. So here's the schedule: registration, ideation, and team formation for 2 hours from 8 to 10 a.m. Hacking, tools, and hardware how-to 10 to 12. Lunch is an hour. Hack for 6 hours. Dinner for an hour, and then prizes for 2 hours. And all I can think is, I can hardly get CAD set up in 6 hours, let alone, actually making something. How would you go about doing this kind of thing?
Yeah, so I mean, nobody's expecting you to kind of walk away from this thing with a complete product. I don't, you've got to have a realistic expectation here. I think the main thing here really is to I think it is entirely feasible to have a by the end of that time have a very solid idea of what it is that you're going to do, and a kind of pretty well sketched out in CAD diagram, okay. of what you're going to make, and I would say probably it depends on the sort of the complexity of what it is that you're trying to achieve, right? I mean, if you're trying to make something very simple and you can kind of piece this thing together out of dev boards, then I guess it's actually feasible that you can have something working by the sort of end of that time. But at the very least, you're going to be well on your way to having something put together. But yeah, I think if there'll be a range of dev boards available. I think that there's going to be some Arduinos floating around, and a few other dev boards. So
Wi-Fi,
I think it's entirely possible.
All that kind of stuff.
So I think it will be possible to put together some interesting projects over the course of the day. But if you're doing something more substantial, I think the goal is to sort of be well on your way to actually making that, rather than actually having something physical in front of you.
Yeah, that does. It's very fast, but I guess as long as there's bounds on expectations, that's what's important. So
yes, that's it. It's to be realistic, and I mean, of course, this is. I mean, to some extent, we are hoping this is kind of a temporary situation, that it will in fact be feasible to prototype hardware over the course of a day and get it manufactured in those timescales, right? I mean,
right.
That's certainly something that we're sort of hoping to achieve at Circuit Hub, is to make that design and manufacture process as quick and cheap as we possibly can.
Yeah. All right. Well, so let's talk about it a little bit. Like, so maybe people didn't listen last time. Could you give us a quick overview about? I know it's been like half hour into the show, but how do you see Circuit Hub? How would you explain it to someone?
Yeah, sure. So basically, we are a crowdsourced electronics parts library, and we work with your existing EDA tool. So effectively, what this means is that you can go onto circuithub.com, search for the part that you're interested in using. You can then click a button, and we will synchronize the libraries for that part to your local computer in the EDA format that you use. So you can then open up your EDA tool, and the part is then available. You can drop it into your schematic, and it comes in complete with footprints and all of your sourcing information intact. Okay,
so when the stuff is stored on Okay, so I guess you kind of walked us through there. So say I find a resistor that for some reason I don't have an 0603 resistor on my current CAD tool, right? And okay, I say I'm going to go on Circuit Hub. I'm going to select it. I'm going to hit download. It'll show up in my Dropbox folder that has been specified. But then there's formats, right, between different CAD programs. So what are the different ones that you have support for?
Yeah, so right now we support Altium, Eagle, and OrCAD.
Okay.
But the goal really is to support every tool. So I know you're big KiCad user.
Yeah.
So that's definitely that's actually been our most requested tool to support. So that's kind of next on the list. But we really want to support all of the tools, sort of Jeddah and the mental graphics tools. Eventually, pretty much everything.
Okay. So when it's on the server though, is it actually stored as like a actual file for like that's specific to Eagle? I forget what the footprint files are called, but or specific to Altium, or are they actually stored like that, or do you guys actually generate them?
Yeah, so I think this was kind of the misconception from your show last week. What we actually do is so we actually let you create the symbols and the footprints directly on the site. So we have an editor where you can input the symbol, put the pins for the symbol in, and we have an editor where you can create the footprint. What we then do after you've done that as a user is that we then convert that to all of the different EDA formats on the back end.
Okay.
So it's not the case that you would upload an Altium symbol, or you would upload a KiCad symbol, and those are then siloed into different EDA tools. It's actually every single symbol and footprint is appropriate for every CAD tool.
Oh, okay. So the upside of that, of course, is that you do then once you add new tools, it's all abstracted out, right? So it's just like pad here, here's the spacings, generate it whatever the rules are for each program. The downside being that you can't, so I guess most people would probably expect that you could, I know I would, that you could then take an existing library, upload the whole thing, but then you have to deal with all the weird part namings and all that kind of crap that's in there usually. So instead, now you say, okay, well, we have to start from scratch. You have to put in, well, not everyone has to, but one person has to put in an 0603 resistor, and then once that's in there, it's then available to everyone, and then it can be sent out to the world. Basically, anyone can select it. Any tool can it can be generated for any CAD tool, and then anyone can download it.
Yeah. So we've taken the decision really that we really felt that this thing had to be universal, right? I mean, there really isn't a kind of leading CAD tool. You speak to 10 engineers and you're going to get at least 5 different CAD tools, and often engineers will flick between different CAD tools for different purposes, right? So
I mean, personally, I use KiCad at home because it's free and I want it to continue being free. But I mean, at work, I never have a choice. It's just like whatever you're forced to use. When I've consulted in the past, I've been forced in other tools, and it's just like, okay, well, you got to learn it. You got to learn it.
Exactly. So you'll end up using these kind of bunch of different tools. And right now, your libraries are going to be siloed into those individual tools.
Yeah.
So you might be creating the same parts if you're using Altium or OrCAD at work, but then when you get home you're using KiCad or Eagle. You can be repeating that same work between the different tools. So we kind of took the view that really what you need is you need kind of one definitive source for that data. And what you want to do is you want to make it really, really easy to create those symbols and footprints, right? Yeah. So that even though you can't necessarily import your existing stuff, you will either find your existing parts already on Circuit Hub, and if they're not, it will be super quick and easy to import them from the raw data sheet. And there's a whole lot of really nice things that kind of fall out of that in terms of being able to maintain a lot of structure to that data. And we think kind of one of the biggest problems when people have attempted this before is that they've not enforced enough structure onto the library. Right. So, you know, you'll find this if you go to component manufacturers' websites, you'll often be able to download you'll be able to download their library, right, which will have like 100 symbols in it and 100 footprints, and then it's 5 years old, and you can sort of pick through it and try and find the appropriate matching things. But by the time you've done that, you may as well have just created it yourself from scratch. Yeah.
Right.
And we sort of feel that the problem there is actually that there's not enough structure in the data that you can trust it. So what we really didn't want is people kind of like mass importing their existing libraries and including stuff that they may have created 10, 15 years ago that they haven't checked, that may not even be correct.
Right, it's like LM324-1, LM324-1-old, LM324-1- don't use.
Exactly.
All of those,
you know. We've all done it, you know. We've all done it, and if you've been designing long enough, then you kind of end up with this this library that, if you're anything like me, I mean, I've sort of carried my library from one place to another. Yeah. And you end up with this, there's stuff in there that they don't even manufacture anymore. There's 5 copies of the same thing because I couldn't find the old thing. And
right, and all the quirks, what not to use. It's, I don't use that one anymore. That one's no good. And then someone else tries to use it, and they're like, "Why did you use that?"
Exactly. This is funny, right? I mean, this is why. I've worked in smaller organizations. I've worked in larger organizations, and it's always surprised me how that people don't even really share libraries in larger organizations, right? Yeah. You'll still have engineers will just keep their library siloed individually, and that's because they're filled with quirks and they know what those quirks are. You don't want to give your library to somebody else and then be responsible for.
And you have legacy designs, right? You don't want to have to go back and then say, was this using the old library versus the new library? Do we actually take when do we make the cutoff? What do you do with all the new stuff then, right? There's just so many different layers. I mean, some of which will actually people will run too, even if they're using old libraries, right? And then they say, okay, well, we're going to start using Circuit Hub to actually use it as a repository. Okay, well, then what about, we're doing this on February 1st. Well, what about designs that were before February 1st, right? I mean, like there really are there's always going to be these kind of backwards compatibility issues that are just tough to deal with.
Sure. So I mean that's really why we said, okay, let's allow people to actually do the creation of the symbols and the footprints on the site, and let's keep that process well ordered as well, and let's record everything that gets done. So I think that's kind of one of the most important things is that pretty much every interaction on the site is actually audited. So if something gets changed, we're always going to know about that, and most importantly, we also know who that change is important to. So, for instance, if you let's say that you use a part that has a symbol designed by somebody else.
Okay.
And they then change that symbol. You're going to be notified of that change. Okay.
It's like a subscription list almost, right? It's like a Wikipedia notice when some article gets changed.
Yeah, pretty much, right? So you'll we actually right now we will propagate those changes automatically. So you will get the updated information, and you'll be notified about what has changed. Now it's then up to you within your EDA tool whether you then want to pull that change into your schematic, right? So your library will have updated, but you can then decide whether you want to pull that change into your whether you actually want to pull that change into your schematic. But you can take a look at the diff and see, okay, well, this pin's moved, or this pin's been corrected, whatever the change may be, and then you can then decide yourself.
So you're saying that okay, so I'm using a part from the library you created, right? It's synced naturally with Dropbox. You make a change to it, I get a notice about it, right? You change a pin spacing to get better voltage spacing, or a pin shape, or a pad shape rather. Are you saying that the Dropbox will then automatically sync it to my computer whenever I'm connected?
Exactly. Yeah.
Oh, interesting. That could be dangerous.
You will know about the change, right? So okay. I think the important thing here is that, you know, this essentially what we're saying is that the biggest thing that we're currently missing from the site is that we don't really have a social proof system yet. Okay. So what is kind of important about all of this is that the way that we save people time is because you don't have to. You can implicitly trust the data on the site, right? So when you look at a symbol, you want to know that is the correct symbol for this part, and you want to know that because 100 other people have said that it is. Okay.
Yeah.
And that is, I mean, that's the thing we're working on really hard now. Is
yeah. So an actual like an active system of like review and checks and balance kind of thing.
Yep, pretty much. That's the idea. So you will you will be notified straight away of any change, and you will have the option to accept that change, and you will also be able to see who else has approved that change as well, right? So
yeah.
if there's a symbol and it's got 100 people say it's okay, well, you can be pretty sure that it's okay. So it's then up to you whether you want to then manually check it as well.
See now, okay, so I was just thinking about how I use a network connected library at my work, right? And I have in the past as well, where it actually and a lot of CAD programs are like that, right? You know, if you're in a company, you have multiple seats of a license, and you have a librarian, right? The librarian being the person that monitors parts and actually creates parts often. I guess those are often changed at the same time as well, right? So if I pull in a part on February 1st, and then the librarian changes it on February 2nd, and then I made a new schematic on February 3rd, then I potentially could pull in a different part. So I guess in that case, you guys are just acting as the librarian, right?
Yeah, pretty much. That's it. Really, is that we allow everybody to act as a librarian for everybody else.
Yeah.
So the kind of core principle is that the more eyes on this, the better, because. I mean, if you think about how this kind of works anyway, like you're going to get sign off from multiple people, right? So if you're creating a library, you'll maybe get sign off from a librarian, a couple of engineers, or something like that.
Yeah.
So we really just want to allow everybody to do that at a larger scale.
Yeah. Well, and that's good, too, because I recall at past companies, it's like, okay, the librarian is going on vacation for the next week. Make sure you have everything you need right now, right? If there's a librarian, then you have a place to go for approval. And then if you don't get it in time, it's like, well, you didn't get it in time. Good luck. It's also Chinese New Year. It's like, screw you.
Well, I mean, you're lucky if you actually had a librarian to do this stuff, right?
Yeah, it's true.
I mean, a lot of times, you'll get stuck doing it yourself. And I mean, personally, for me, that was never one of the interesting parts of the whole design process.
That's true too. Yeah,
I always kind of hated that point where you've selected pretty much most of your components, and you know how the design's going to look, but now you've got to get it all drafted up. And then you sit there for the next 2 weeks getting all your symbols and your footprints in order, and it's a painful process. And
it's actually different tool to tool as well. So like you guys cover both Altium and Eagle, right? And I know that in Eagle it's actually linked together, where because I'm pulling LM324, it already has a footprint associated with it. If there's an LM324 SOIC8, then that might have an SOIC8, whereas the other one might be like a DIP package, right? And so that's actually connected at when you pull it in your schematic. A lot of tools like Altium, KiCad, a lot of those, you're actually just putting in the schematic symbol, and then at the time when you're pulling it into the layout side, that's when you assign the the package type. And when I first switched over to Altium, because I'd used Eagle first, and I'd used a couple others before that, I had never done that association before, and that's when it really hit me that you're the librarian at that point with those kind of tools where you're pulling it in like that. If you don't have all the footprints set up and in an easy to recognize manner, then you're you are now a footprint maker, you know?
Yeah, exactly. I mean, it's funny actually. I mean, there's a compromise there, right? I mean, ultimately, at some point in the design process, you are going to have to make those decisions, and I think different tools just allow you to make those decisions at different points in the design phase. So I think you tend to find with a kind of a lot of the professional level tools, they require you to kind of get everything correct up front. So they kind of work on this assumption that you're going to have a librarian who is going to produce correct data, and then you're then going to go on to step 2, which is design it into a schematic, and then you're going to go on to step 3, which is put it into a layout.
Right, and those might be all different people every time, right? It might just be different steps in the process, very siloed. So you have these handoffs that have to be very discrete. Exactly,
and then some of the more the tools for hobbyists. If you look at something like Eagle or KiCad, then they're much more free-form, as in they will let you place just a schematic symbol, and then at the point at which you're doing layout, you get to do the association.
Yeah,
and there's benefits to both. There's benefits to both, but I think if you think really about why people want to do the second process, it's because they don't want to have to think about library creation up front but that's really a shortcut, I think, to the correct solution, which is just that it should be super easy to have.
Yeah, short term versus long term, right?
Yeah, it should be super easy to have 100% correct part in your schematic straight away.
Yeah.
And the reason people don't do that right now is because they don't want to go off and spend an hour creating that correct part. But if it was very easy to just click a button and have that 100% correct from the beginning, I think people would probably do that.
Well, I plan to.
Fantastic.
So tell me about your target audience here, because throughout all of this, all I can imagine is past mentors, current mentors, graybeards galore in the analog field, just kind of sitting in the corner, just shaking their head no, and just scowling at me. No, you're never. You cannot. You're not. No, do not do that. I will rip you apart at your design review. So what is your target audience here? I mean, is it those guys or is it someone else?
Yeah, I mean, it's we're really building this for ourselves. I mean, this is
all right.
This started as a passion project, first and foremost. This really started as a passion for never having to do library management again. Which
that's the best projects where it's like I am so pissed right now. I just have to fix this. I will learn web development.
It turns out though the logic for that is actually slightly backward, because when you start a business to deal with something that you hate doing, it turns out that you end up doing that all of the time.
Oh, right, yeah. But it's like you're like a martyr, right? It's like I am taking this pain upon myself, so you do not have to anymore.
Exactly. That's the and there's don't get me wrong, there's a lot of other fun aspects to it as well. So
the funny thing is that you can get so fried from it, doing it so often, right? As you are working on this, that you may never want to you might not even remember how to do it by the end, right? It's like you're so deep in all the details of everything, and it's like you get in all these obscure corner cases that it's like, well, what do you mean I just hook up the footprint?
Yeah. I mean, I'm personally really looking forward to getting back and doing some electronics design and kind of actually being more on the usage side of Circuit Hub. It's something I haven't had the opportunity to do for some time now, so I'm sort of looking forward to that. But I mean, sort of in answer to your question of who it's for, I mean, both Jonathan and I, Jonathan, my co-founder, have done electronics at pretty much every level, from tinkering around with stuff in our garages, right up to consulting for large corporations, and we are basically making this for ourselves. So we hope that it's going to cover the full range. Now, in practice, that means that you're always going to get, shall we say,
cranky pants.
Your early adopters are always going to be people who are much more flexible, right? And if you are a kind of hobbyist or a one-man band, then you can just turn on a dime and you can say, okay, this looks cool, I'm going to use it. But if you're working at a large in a large enterprise environment, then you've got to go and convince 10 people that this is what we should be doing, and then that sort of stuff takes a lot longer. So we really anticipate.
And you might have a librarian that doesn't want to lose his or her job, so then they're no, you can't do that.
Yeah, sure. I mean, but I mean, the interesting thing there is, right, that librarians do use tools, so there's nothing to stop. There's nothing to stop your librarian using Circuit Hub and then just becoming more productive. We think this is very much not a zero sum equation here. There's a lot more. I mean, we think that if it was easier to design and manufacture electronics, there would be a lot more electronics in the world. Okay.
Yeah. I agree.
So if we can sort of make this process easier, there's going to be, it's hopefully just going to be great for the industry itself. That's perhaps quite a grandiose thing at this stage when we're a small startup, but that's the dream.
Well, that's okay, man. You got to dream big. You got to shoot for the stars. That's important. So what about like the public versus private type of thing? I mean, so like you mentioned the big corporation type environments, right? Where, but I know that ones I've been in before, if you went to someone and said, okay, well, I have this great tool and I have it so that, it makes it easier on the librarian. There's, it allows multiple ranges of feedback for part creation. So you really cut down on potential errors, and then you say, but also it's on the internet, so you're pulling from the internet, and other people are seeing your footprint designs, and then everybody goes, and then you get booted out the door. I mean, is that something you've run into yet, or is it just like who cares?
Yeah, so I'm surprised actually that we haven't run into this issue yet. It's was something that I was also worried about, I guess. I think there's probably I expect we will at some point. I'll say sort of first, but I think you've got to look at corporations becoming a lot more open in general. The kind of use and publishing of open source, both in terms of software and hardware, and how much information are you giving away, or how much kind of intellectual property are you giving away by publishing your symbols and footprints,
right?
And if this corporation thinks that is too much information, then they can choose not to use Circuit Hub, or and if they think it's okay to be giving that away, then they can use Circuit Hub. I mean, right now, all of our default policy is that pretty much everything is public, right? So if you create a symbol or you create a footprint, it's going to be public by default.
Yeah.
That's not to say in future that we won't have privacy options. That's potentially something we could look at if there was demand for it.
Well, it's interesting because I thought about it like, well, you could, at you guys as a company, at Circuit Hub as a company, you could eventually, package it all up and sell it to an enterprise, kind of like how Google does with like Gmail and stuff like that. They actually sell servers, right? But at the same time, it's like the entire value of the thing is that, no, there's lots of people looking at it. If you then constrain it to, 50 or 100 engineers, then you run into the same problems that you have with the library now. The actual value in it is that there's more people looking at footprints, and especially on common parts, right?
Yeah, I mean that's exactly what we think. Is that we want to try and avoid this getting fragmented, because the value is in having one place to go for this information, and if we start creating, we're just going to contribute to the problem if we allow people to go off and create their own siloed libraries. We could, for instance, provide a kind of enterprise install, but the real benefit is if we can just get everybody to contribute to this one shared library, then it seems to me like there's this crazy situation right now where there's so much duplication of work. And I think what frustrates me most about this is that it's duplication of mistakes.
Right. Yeah.
And those mistakes are just incredibly costly in time and money if you get something wrong in your symbol or footprint, and you get that all the way through to fab, and you get your board back and it doesn't work, and you spend 3 days figuring out why it doesn't work, and then you realize that you mixed a couple of pins up.
Yeah.
Which has happened to us all.
Oh yeah, I was going to mention before when you were talking about sharing libraries with someone else. My first board working in a corporate environment, I borrowed senior engineer's library, and I'm like, of course it's going to work, right? And then I get my first board back, spend 2 weeks debugging it, and then find out because footprint errors are so hard to detect because it's the last thing you expect.
Mm-hmm.
I found it. No, yeah. That enable pin. Yeah, you weren't doing that right.
Exactly. I mean, I've just seen it happen so many times.
Yeah.
It's going to be happening on the same parts for different people because everybody's creating their own siloed data. So it'd be much better. I mean, if that mistake has to happen, then at least let's have it happen once, and then that should be the only time that the mistake happens.
Right.
And that, I think, that is going to be the real benefit of Circuit Hub, is that if there are any mistakes in the data, we'll try our hardest to make sure it's 100% correct. But that's the goal. But the kind of backup plan is that if anything does go wrong, then it only goes wrong once. And it goes wrong the first time, and then for everybody else from then on, it's all the data is correct.
Yeah. Well, and it'll be nice as you guys, continue to grow and continue to get numbers, right? If you have some kind of feedback mechanism for, okay, this part was wrong, right? And you have that, I don't know if there should be some way to compare it to like a individual installation environment where, like a big corporation where, okay, this happens twice a year versus, once a year with Circuit Hub, that kind of thing. Like, if you have those kind of comparisons, then eventually that kind of adds to it. But, you need to get that momentum going first to actually have all these cases and have, basically, if something's going to go wrong, you need it to happen so that you have the data, right? You can't just look and say, well, nothing's gone wrong yet, so 100% effective.
Yeah, exactly. Yeah.
That's a tough
Yeah,
sell.
I mean, clearly, yes, we need to sort of get a bigger library available. I mean, that's really one of our focuses right now. Is just to get a whole bunch more content on the site, and to keep that content as high quality as we possibly can.
Right. Yeah, I mean that's another thing I was going to ask you about. I mean, how you mentioned the fragmentation and siloing of libraries and footprints and everything else. How do you become the one, right? I mean, like that's the tough part. That with a concentration of power like that, how do you? I don't want to say power. That's not the right word, but the concentration of information like that, there is risk in that, and I think that's what some other people look at and they say, well, I don't want it to just be based on one company or one thing. I mean, how are you guys trying to fight back against that concept of needing to get that mass?
Well, I think the kind of base in the whole that we've got there is that you end up with all the data on your computer, right? So you can at any time decide that you don't want to use Circuit Hub anymore, and you then have you've lost nothing in terms of you all of your data is still intact. So you could simply go on, unlink your Dropbox, never log in again, and you're still going to have all of the libraries that you had before. It's all copied locally to your computer. Of course, you're now back in the Stone Ages. If you want to then do any more design work, so it's probably not a good idea.
I'll just zip up my library and send it to you.
Yeah, exactly. So, but I think that is I think that gets around a lot of the kind of fear of sort of tying yourself to one service.
Yeah, I guess a lot of my concern would be, if I was going to a service where it started out free, right, and then eventually it's like, okay, well, it's the new year, and now it's $100 a month to access your footprints that you put in. If it was like that, then that's really dangerous, right? But if it, like you said, if it's all locally, then that helps a lot.
I think the other thing that, I mean, trust is something that you accumulate over time, right?
Yeah.
It's we have pledged that what you currently see on Circuit Hub in terms of all of the library management will always be free. We will never charge for the core product that you currently see, and we think this is kind of where efforts in this direction have failed before as well, is because a lot of them have kind of been paid for products, right? So the question, or the proposition to people is, okay, you pay me money and then I will let you contribute to our library and we will then share that to other people, okay? Which is just entirely different to this is a publicly available resource for everybody to use. So we really felt that the only way to do this was that it had to be free.
Right. Well, the other model there is, you pay me money, and then we'll get someone here to do it. Well, we'll get someone here to make library footprints, right? Like having an on-site librarian instead of the users making it, and then it's a subscription type service as well. So that's another option which is out there.
Yeah, it's there are pros and cons to both approaches, right? I mean, we just think that we really just want to concentrate on making this the easiest way to manage your library, and just keeping that free and available for everyone. The thing is that if you there should be a shared resource for everybody, so that everybody sort of hates doing this process, right? Everybody hates library management. Let's just allow everybody to help each other out, take some of the workload off each other, and then just and get this problem nailed. So that is always going to be free. And in terms of the trust issue, as in okay, well, is this thing going to be shut off 6 months from now? That's really something that I think you accumulate over time. As we're around for a longer period of time, people will we were aware that we have to earn people's trust.
Any plans to open source any of the code or anything like that?
Yeah, we do actually. So we very much want to open source a whole bunch of code out of this. We've got, I think we currently have about 20 open source projects on GitHub.
Okay.
If you go to github.com/Circuit Hub, you'll see a whole bunch of stuff that we've put up there. Our kind of default policy internally is that it's open source unless you can come up with a good reason why it shouldn't be.
Yeah.
So it's like we kind of on almost everything. The default is, well, it's public, and then you've got to come up with a damn good reason why it shouldn't be public.
Right.
And the main reason for the kind of main web application not being public is to keep everything secure, and also to some extent to avoid fragmentation. Right? We don't want kind of Circuit Hub 1, Circuit Hub 2, Circuit Hub 3, and then the whole value of this shared library gets diluted. We really do think this kind of one shared resource is worth doing.
Yeah, no, that's very true. And it kind of reminds me like a Stack Overflow type thing where the back end is all open source. You could run your own, but at the same time, the value again is in the people. It's in the critical mass of information there, right? That's what they go for, and that's why it's been successful.
Yeah, exactly. I mean, we really sort of see it that we're building a tool to allow everybody to kind of curate this library. And what's going to be really valuable there is this big shared library of information. Very much like Wikipedia. So we definitely want to. I mean, we build on pretty much almost exclusively on top of open source. So I mean, we're big users of Node.js and MySQL, and the whole stack's kind of Linux from top to bottom. So we use an awful lot of open source, and we definitely are and want to contribute more back on that front. I think for me, it's just a really cool way that companies are going. Is that I think there's this kind of great model that I think is also applicable to hardware, where you kind of, it's almost like 80% of what you do is common across everyone, right? So in software, you use these open source software projects. In hardware, you use publicly available designs, and you then take that and you add your extra sort of icing on the cake, which is your kind of differentiator. So that's really what we want to do, is kind of make as much as possible open source, and then sort of keep our little twist on it on the top.
So what about so you mentioned the core tool will always be free, but what about eventually, I'm guessing your generous investors would like you to make some money.
Yep.
So what are do you have any potential plans for that kind of thing, or is it more of a work in progress?
Yes, I mean there's really there's sort of two things that we set out to really crack, which is the design and manufacture of electronics. Okay. So we will be moving a lot more into the kind of manufacturing side of things. And
I like it.
Yeah, that is kind of really where our business model is much more to do with the manufacturing of things, and then that allows us to, or the hope is that will allow us to, keep all of this information public. Because we have this business model on the back end.
Yeah, that's great. I mean, that's what a lot of great businesses have been doing with being able to have a big community like 3D robotics, right? Chris Anderson's company, very similar.
Sure.
DIY drones isn't officially part of that, but there is this big open source community that's funded by a lot of help from smaller companies behind it, and then there's actually a commerce component to it as well. So that's great.
Yeah, and I mean, I think this is it's a kind of great model, I think, that works well here, because it just allows us to, in one way or another, it would be very difficult to do Circuit Hub, I think, as a kind of a completely open source amateur project, and I can tell you that because I tried. John and I actually both tried to do this, right? We were kind of just doing this as a spare time thing. The idea is that, we would just work on this in our spare time, and we'd throw it up there, and, hopefully people get some use out of it. But the trouble is, it's kind of just such a big problem, and you really just need a lot of focused effort to get it solved. And one of the most effective ways to do that is to turn it into a company. So that's what we've done, and then obviously that means that we then need this sort of business model on the back end. So that's where the kind of manufacturing side of things comes in.
Well, that's very cool. Can you tell us anything about it becoming a company? I mean, how did that get started then? I mean, if it was a hobby project, did you go and approach Y Combinator, or who was the other one? Google was funding some part of the company as well.
Yes.
Where did it all start? Was it you approaching them approaching you? Was it kind of like a little bit of both?
Yeah. So it was basically I mean, this is something that I've been thinking about for quite some time now, and had basically kind of sort of started hacking around on, and I was kind of sort of busy putting together a sort of prototype for Circuit Hub and doing a bit of research at the same time, and I came across a paper that my co-founder Jonathan Friedman had published over at UCLA, and he had basically published a paper that was kind of describing a lot of the same pain points that I was experiencing, and some similar aspects to the system that I was building at the same time. So I think initially sent John an email, and just said, hey, this is cool. I'm working on something similar. We should probably have a bit of a chat about this. And we kind of exchanged a few emails back and forth. Found out we had an awful lot in common, and I actually ended up going over to John was over in LA at the time, so I ended up going over to see John, and we just had a complete mind meld, really. We were both electronics engineers from, as I say, from hobbyists, from being very, very little and doing this thing on an amateur level right up to doing it professionally. And we just chatted for pretty much a day straight, and that conversation pretty much consisted of us both complaining to each other about how electronics is currently done. So,
I have no idea how that works. I have never talked to another person and just complained to them for an hour a week every week across great distances.
Yeah, that's really how the conversation would go. It would just be like, oh god, I'm so frustrated with this aspect of electronics design, and then we would just sort of fight that back and forth, and we just really had a meeting of minds there. So after so I sort of stayed over there for a few days, and then I ended up coming back to London, but we kept in touch, and kind of at that point, we didn't really sort of think, oh, okay, great, we're going to go off and do this startup and sort of do this thing seriously. We were kind of like, cool, let's work together. We both see this common problem, and we're really interested in it, and we're both working on it anyway. So let's see how we can get this thing working together. We basically just sort of carried on like that, really. We were both sort of hacking away on our solutions. John was actually working primarily on the kind of manufacturing side of things. I was working much more on the parts library side of things. So it fit together really nicely. We both saw exactly the same problem, but we'd started from different ends. So we were like, this is great. I'm you're working on one end of the problem, I'm working on the other. Let's join up, and we kind of got a complete solution to this. So then probably over the course of a few months, we sort of started to realize, okay, well, maybe we've got something here. This looks pretty interesting, but we really need to put some concerted effort into this and actually sort of do this full time. So we kind of I would say it was towards the end of last year. We put an application in to Y Combinator, and I think this was literally the deadline day. I think I was looking at a post on Hacker News.
Nice. I'm sure that they get tons of good stuff on the last day.
Yeah, I sort of remember actually, because there's a post that goes up basically saying it's deadline day. And I sort of saw that up on Hacker News. I mean, I've been reading Hacker News for years. Anyway, just all sorts of interesting stories on there. Saw that go up and thought, okay, well let's ping an application off and see what happens. Didn't really sort of think too much more of it. So we did that, and lo and behold, sort of a month later, we got invited for an interview over in the Valley. And so we ended up going over there. Something must have gone right in the interview, and they asked us to come and participate in the Winter 2012 program.
Wow.
Which I think what they saw was that we were it's funny actually, we kind of did exactly the same thing that we did in our initial discussions, but just did it in an interview. So really just sit there and complain to people about how electronics is currently done. It's so we just like you really just sat there saying how much work is currently involved in this process of electronics design, and getting how tough it is to get things manufactured. And we both felt all this pain doing it, and I don't think they really had a clue what we were going on about, right? Because these are all software guys.
Yeah.
Aside from so fortunately, actually, Trevor Blackwell, who's a partner at Y Combinator, he's actually a robotics guy.
Thank God.
Yeah. So that was awesome. Like we were able to. Trevor was sort of really understood what we were going at. But everyone else is kind of software guys.
I just imagine them looking at you and being like, "Oh, look at the little hardware guys trying to do web applications," and then you being like, "And also I know electronics."
Exactly,
yeah.
and of course, even and this was the start of the year, right? When hardware was still pretty uncool.
Yeah, which is crazy. There's been a year.
Yeah, exactly. I mean, it is crazy to think how much has really changed in this last year. I mean, there's been quite a few, I think, pivotal things that have happened, but back then, hardware was still pretty uncool. So we were really surprised actually to be accepted. Everybody else is doing these sort of social mobile Facebook sales type things, and here we are sort of. We want to make this, universal parts library, and everyone's like, "Well, what's a parts library? Why do you need that?" And then, we have to explain everything from base principles, and then
we'll make you a video.
Yeah, I mean, one of the first questions we always, or one of the most people tend to be surprised that this thing doesn't already exist, right? Like, so you explain to them what you're doing, and then people are like, "What? So this doesn't already exist?" And we're like, "No, it doesn't. That's why we're building it."
Yeah.
So some sort of quite interesting conversations there. But I guess I just saw that we were passionate about what we're building and building it for ourselves, and decided to take a punt on this.
That's great. And then Google also got in on it somehow. I'm not sure how that stuff. I've heard that once you get some funding, then other people sometimes come in on it as well.
Yeah, so I mean, the way Y Combinator works is that you essentially spend you spend pretty much 3 months coding for 20 hours a day, and yep,
Jesus.
and it's pretty intense, right? I mean, I think probably the single biggest benefit of Y Combinator is like the almost like the weight of expectation, because everyone around you is working so hard. It's kind of difficult not to as well, right? I mean, if if the guy next to you is working 20-hour days, well, you're going to work 20-hour days as well.
Which can suck sometimes, but it sounds like a very exciting situation there.
If you're working on something that you love and you're passionate about, it's not so bad, right?
Right.
I mean, would I sit in front of a computer coding for 20 hours a day out of choice? Probably not, but for a kind of for a period of time, it can be a bit of a rush. So
I just meant like if you were like on a salary, right, and then you're forcing you to work 20 hours a day. That's when it's like that's what I think of initially, and then it's like no, but if it was like in my lab, it's like that's my weekends, it's like that's great,
I've done it at jobs as well. I mean, I think it's more about if you're interested in what you're doing, I suppose. It's kind of this intense period, but then in the end of that, you do what's called demo day, which is where you present to investors, and that is basically you do a very short pitch and you explain to people what it is that you're doing, and hopefully you've got some business behind what you're doing, and from that you then attempt to raise investment in the kind of weeks after demo day.
So did demo day already happen?
Yes. So that happened. That was in March for us. So we did that, and then we sort of we actually closed our funding round sort of pretty quickly after demo day.
Oh, so this is all last year.
Yep. So this was.
So it's been almost a year now.
Yeah, I mean, since we started Y Combinator, pretty much just a little over a year now, and it turned out. I mean, we were actually in quite an unusual situation compared to most other people, because the problem that I would say probably the vast majority of Y Combinator companies have is that they don't know that they're making something that people want, but the actual technology to produce it tends to be quite simple. So if you're making a photo sharing application, for instance, then the actual technology side of that is pretty easy. You can put a prototype together inside of a week. But what's really difficult is figuring out whether people want to use it and building something that people want. Now, we kind of almost had the opposite problem, which is that if we can make this, people are going to want it. But it's a very technically challenging project. And actually figuring out exactly how all of this stuff should work and how we're actually going to go around building it was actually a huge chunk of work, which is I guess why we have taken sort of quite a lot longer to release than your typical web startup, is just because we had an awful lot more software to write.
Yeah. Huh.
So it's kind of a different problem to most YC startups, but in some senses a nice problem to have, I suppose. It's at least technical problems can always be overcome. It's just a case of how long it takes.
Right. Yeah. That takes a little while, huh?
Yeah.
Well, that's great. That's really great. I didn't actually realize. I thought that you guys were still in the Y Combinator part. I thought you still had a demo. I didn't quite understand that. So that's really interesting though. And I heard that some of the so we had seen a tweet from Paul Graham, one of the guys that runs Y Combinator, that some of the that there are more hardware startups. They're doing more hardware startups now. And then there's accelerators that do that same kind of thing. Bolt starting up, and then Accelerators, one we've talked about before. And I think there's other ones as well now, like Lemnos Labs and a couple others, where there's actual accelerators happening.
Yeah, for sure. So unfortunately, I don't know which of the YC hardware companies are actually public yet. So I'm not gonna out any of those guys. But there are there's a bunch of hardware startups inside of YC now. And I think you can tell from PG's tweet that they YC see quite a lot of promise in hardware startups, and this is as we talked about, it's a pretty new thing. We had I guess in our batch a couple of we had I guess one genuine hardware startup in our batch, Pervices, who are doing software-defined radio.
What was the name of it again?
Sorry, I think I mispronounced that. It's Pervices. So it's Pervices, I think. Yeah, Pervices. And those guys are making a software-defined radio, which involves a big hardware component. So they were probably the only genuine hardware startup in our batch. There was a couple of other companies that were kind of toying with the idea of making some hardware. But now it's a different kettle of fish altogether. There are quite a few genuine hardware startups going through Y Combinator as we speak.
It is an exciting time to be in hardware, that's for sure.
It is. I said to you before the before the interview, I'm kind of it's slightly frustrating to me to be going the other way, to be going from hardware over to web development, and all the cool kids seem to be going from web development over to hardware now. So
that's okay, man. You're just bucking the trend. I'm sure in a couple months it'll swing back or something. I'm unfortunately stuck in the hardware side because I have no clue how to code.
It's surprisingly similar, right? The problems are it's all engineering at the end of the day.
Yeah, you've never seen my code though. It's So one last thing I wanted to mention was so you're actually calling in right now from Mexico, right?
Yes,
Mexico?
I'm indeed. Yes.
So what is the reason behind that? We were talking about that a little bit before the show, but there's actually it's kind of relevant to news right now, right? So you don't have citizenship in the U.S., but you're being funded by a U.S. company as well. So what's the deal there?
Yeah, so we're kind of in this crazy situation at the moment where it's actually incredibly difficult to get a visa for the US if you are a founder of a company. I hold a British passport. My co-founder John has an American passport, so no problem there. And we have team members from South Africa and the Ukraine.
Wow.
We've actually recently just managed to get pretty much everyone except me into the US. And
just a founder, whatever.
Yeah, exactly. It's this, and unfortunately, it's a very common story. The immigration system just really isn't set up for sort of modern startups. It's kind of, I think, a lot easier if you are, if you're a founder of a large publicly traded company or something, for instance, then these things get a lot easier. But if you're actually kind of doing a startup on a smaller scale, it's still incredibly difficult to get into the US. We are currently, or we are going to be convening in Mexico for the next 3 months. Getting a team together here. I've just spent the last week getting a place sorted for us all to work from. And we're going to be working out of a sort of work, I guess, apartment or condo, as the Americans say. So we'll be living and working out of that for the next 3 months, which has some fringe benefits.
Yeah, well, are you ever on the coast somewhere? Is it?
Yeah, so actually, in Playa del Carmen, which is it's kind of about it's about a 45-minute drive south of Cancun.
Could be worse. You're right. Could be worse.
Yeah.
Oh, it's right across the bay from Cozumel, huh? It's right across the strait there.
That's it. Yeah, I mean, it's a very nice place to work from for a few months. It's pretty it's pretty quiet and a good place to get some stuff done. I can't say the same for 45 minutes north from here. I think Cancun is a bit more rowdy, a
little more party oriented. Yeah. I mean, you compare it to London too. I mean, right? I'm sure London is very similar to Cleveland in February. Well, maybe might be a little snowier here, but it probably doesn't hurt to go to Mexico.
It was snowing, yeah, but bright sunshine here. So that's kind of one of the fringe benefits. We figured, if you've got to be stuck in front of a computer for 20 hours a day writing code, then it may as well be sunny outside.
Yeah, so maybe we don't need reform after all. Just have every startup go to a tropical location, which is crazy, right? I mean, like, you think about it. So first off, I totally agree with you. That is totally ridiculous that that's the case. I mean, I think any country that U.S. Irregardless of this, any country that doesn't let in companies that are gonna create jobs and do startups and have taxable revenue and stuff like that, countries that don't do that are ridiculous. But that being said, the U.S. is going through this right now, and there's a little bit of support for it. But man, you just think it'd be so much easier, and it's a damn shame it's not.
Yeah, I mean, it's funny actually. It's a lot easier going the other way into the UK. We actually, it's far easier to be a founder going into the UK. And I would guess probably elsewhere in Europe as well, but it's just particularly difficult to the States. I don't know why that is. I mean, there's a whole bunch of interesting stats out there. I mean, if you look at the problem logically, it's clearly the wrong situation. There's an tremendous amount of startups that are founded by immigrants, and it's something that needs to change, and I hope it does. I mean, we just kind of take the view on it that it's not going to hold us back, and this is one of the other nice things, I guess, about doing a web startup versus a hardware startup is that we can be a bit more sort of flexible in location, because pretty much give us an internet connection and some laptops and we're good to go.
Right.
So
that and some energy drinks and some Funyuns and everything else, every other stereotypical coder food,
pizza
right?
And Red Bull. Yep.
See, now it has to be tacos and Red Bull. If you're Mexico, right? I'm sorry, anyone that speaks Spanish. I apologize.
Yeah, they have all sorts of crazy energy drinks out here, so I'm sure we'll be sampling them at some point during those late nights.
Oh, that's great.
We've been working as a distributed team for for I guess the last few months. So it's it's nice to sort of get everybody together in the same location and sort of do that for a few months. Makes a nice change.
Yeah, definitely. Well, I've taken up a lot of your time here, and I really appreciate you talking to me about this and giving our listeners a chance to better learn about Circuit Hub. What can our listeners do to help contribute? I mean, is it just kind of sign on and start making footprints, or are there tutorials to get into workflows easier?
Yeah, I would say we need as many people as possible to to contribute parts and symbol information. So it's pretty quick to sign up and take a look at the tutorial. And you can kind of see how the process works. We're making it easier, but it's pretty easy right now. And start creating parts and symbols and footprints and using the site. I think that would be the best way to help out.
Are you guys doing? Have you taken any notes from your fellow YC companies that like having badges and check-ins and that kind of thing on the site? Is there some way you can share that? Oh, I've got the SOIC 8 footprint on Circuit Hub, and go check it out. That kind of thing.
Yeah, maybe there's a
maybe
we'll see.
I think as much as it sounds ridiculous sometimes, I think incentivizing and gamification, sometimes it can be kind of weird. But like Adafruit's like badge system, I love that. I think that is so great. I mean, not even just for kids, but just in general. Having a way to show that you're contributing. Like there's pride in it, and there's also there's legitimacy in it. There's something you could potentially put it on a resume or put it in a portfolio.
Yeah, that's interesting. Actually, I mean, it's definitely something that we're going to be looking at. Yeah.
Cool. Well, in the meantime, people can find you on Twitter at Seddon Andrew, right?
Yeah, that's the one. Yeah. So last name, first name.
And then Circuit Hub is also on there?
Yes. Yeah. So twitter.com/Circuit Hub, and obviously circuithub.com.
Yeah. Yeah. Of course. People should probably go there first.
Yeah, that's probably your first stop.
All right, great. Well, Andrew, thank you so much for being on the show. We really appreciated hearing about it, and we look forward to seeing your progress and seeing Circuit Hub become the place for finding and contributing parts and footprints.
Fantastic. It's been a pleasure, Chris.
All right. Well, people should check out circuithub.com, and see y'all next week.